So, Mike, tell us a little bit about yourself.
Okay, so I started off as a naval architect working at Holland and Wolff over 20 years ago. And then after being there for a couple of years, came to Aberdeen, pretty much with the same company I'm with now, starting as a subsea engineer, just doing pipelines, that sort of thing. And other than 2 years out at an installation contractor as the engineering manager, I'm now MD of the same company over 20 years later.
Good story. Can you tell us a little bit about what you're going to talk about today?
So I just want to share with you something that we discovered almost by accident that our new owners or owners of 4 years have been using for years, and just it struck something with us that we could use it here, and I've had the opportunity to steal it, and they've developed with it. So I'm just going to talk through what it can do.
Super, thank you. And Charlie, can you tell us why it's of interest to the OGTC and to the wider industry?
Yeah, so I'm from the Small Pools Solution Centre, marginal fields in the UKCS. We're obviously very keen to reduce the life cycle costs of the assets out in the UKCS in order to make small pools economic. This is a piece of software that we think is really interesting for that. We're very keen to take learnings and software and technologies from other industries and apply them to oil and gas as well, which this covers really nicely. And there's a clear overlap here between ourselves and our Digital Transformation Solution Centre. Give us a wave, Alex. So if you guys are interested in any of that kind of stuff as well, do please grab some of the digital transformation people in the room. Anyone, by the way, from OGTC is here with one of these colour lanyards on if you want to have a chat with any of them. So thank you.
Thank you, Charlie. Okay, on that note, I will hand over to Mike, who will hopefully be able to timekeep much better than me.
No.
Your 20 minutes start now.
I think I've managed it to 23 so far, and that's about it. Hang on, that's it. I'll remember how to use it. So yeah, thank you for coming. I was hoping it was going to be more than just me. As I said, I want to share about something called ModSim. And ModSim is nothing special. It's not a trade name. If you do a search on Google, it's just modeling and simulation. It's been around for a long time. And it's called ModSim, the system that I'll show you, just because it's easier to say than modeling and simulation. We are part of a company called Huntington Ingalls Industries, which, if you don't know, is probably the largest shipyard in the US, which builds all of the nuclear fleet, aircraft carriers, submarines, and everything else. And we were actually talking, they came over and we were talking about sort of nuclear decommissioning and some of the things down around Sellafield and some of the services that maybe we could to work just from an engineering background. You know, we're a subsea company, this is our 30th year, and it was a possible diversification as we were all looking for other things to do. But one slide in this pack of their capabilities jumped to us, which was this, and I'm going to play this whilst I talk, and hopefully it will work. In their building of aircraft carriers, they have a performance standard that they have to meet, which is, for an aircraft carrier, it is trying to get as much flight operational time as absolutely possible. So as part of the design of the carrier, what they have is one of the suites that they've developed is this system which basically is modeling every bit of data and information in the operation of an aircraft carrier. Basically, this is a simulation that they use during the design, looking at the site, looking at how do they sort of set up the deck, how do they set up everything else. And just to give, I mean, you can see there's a little bit of a legend at the top, but you talk here about having refueling points. You have elevators for bringing ordnance up and down from deck. If you see these little yellow ants dotting around everywhere, they're people. And everything's modeled in here, down to every single tool, spanner, everything. And what they use that here really is just to make sure every plane is up in the air for as long as possible. It goes through all of the logistics, moving everything around. It goes through pre-ops, maintenance, and it accounts for aircraft breaking down. It accounts for any of the equipment getting broken, like the catapults, all of that. So, and it runs through all the different phases, whether it's landing, takeoff, wave off, where the deck's a bit too busy and aircraft pass by. And we saw this, and other than it being a really cool simulation, actually what you suddenly start to realize is, and the way they talk about it in the shipyard is this is just a big factory. and it's a self-contained unit. It's its own set of space. It's remote from anything else. It has its own set of assets which are limited. And the more and more you think about that, the more you realise there's no difference between that and all of the platforms we have in the North Sea. And so actually then we started to say, well, actually, what can this system do? And I mean, as you can see, other than it being really cool for looking at and watching, and I'm really lucky to be able to use this, you suddenly realise that actually behind this there is so much more than that we would do. You know, to try and do that on a P6 plan, and I guess that's really where I'm trying to get to. This takes all of the data and uses it in a real powerful way. And I'm going to just quit that. So we saw that and we started talking about this system and asked them what was it. And what I want to talk about really now is just where's it come from, and the fact that this isn't just a simulation, a pretty graphic that I can show you about something we want to develop. Actually, this started back. 95 is the first significant sort of development. And actually, some of the development started well before that. So this thing has 25 years of development. Started off with really just a virtual initial development of a virtual carrier, or I think it was a carrier, with all of the tank models allowing them to look at it. And in fact, when I said at the beginning, I started in Holland and Wolff, when we did, I was there for Schiehallion, yes, I was there for that. We actually had a room that was a 3D virtualization of the FPSO. The hull was made by Holland and Wolff, topsides, Brown and Root, and the turret by SBM, and we tied it all together and we had virtual reality. But it really sort of ended there, and as much as we talk about those technologies now, for me that was 97. You know, it's been around for years, and we're still only talking about it as a new technology now. So then they went through looking at the manufacturing process and all of the data and the modeling around that. They moved through actually how do they represent that in the real world, how do they work through it. They started talking about it with the world in about 2000. They then started to draw all of that together to create a totally virtual warship. They then went on to using that in real-life training programs. In around 2006, by the time you get to like 2007, 2008, they've got the virtual sub and various other bits. They then moved down to completely modeling all of the activities and the processes, fully 3D, in the shipyard. And then they moved into the nuclear industry and power plants and just refueling and how you manage all of that and decommissioning of nuclear plants. And it's not that then you've got this big gap to where we are now looking at a platform. Actually, that's development. They've been using it in anger for 15, 20 years. So this system has got credibility. It's been used in anger. And some of the stats that I have, if I can remember them all, is they've used ModSim on the refueling of an aircraft carrier to knock 20% off the schedule. It knocks like 5 months off of some programs. It's knocked 7,000 hours off of your average package development. It has a huge amount of credibility. It saved millions of dollars. So when we've looked at that, we've said, well, can we nick it, please? And they said yes. So we've spent the last 6 months working with one operator and talking to a few others about how can we use it offshore. So, you know, that's military, that's great, and that's huge, and it's big budget. But actually, when you look at what we're doing, it's exactly the same. You know, we are looking at hugely complex projects. I mean, an aircraft carrier, especially a nuclear one, is, you know, probably much more complex than our platforms. But actually, in reality, it's not that different. Okay, the values are very different. But they've looked at how do we use technology, and this objective is how do we do things predictably. You know, so we've taken an offshore platform and we've said, okay, let's just look at shutdowns. Let's just look at one small subject. Can we use that in the same way they use it in the shipyards? And the answer is yes. You know, we're looking at how do we use technology? How do we use sort of virtualization of all of the stuff that we have? You know, the system itself can take almost any type of input, whether it be cloud point surveys, which is the laser scan. It can take 3D models, Inventor, PDMS, and it can suck all of that data in, basic drawings, GIS, all of it can be brought in quite readily and quickly. along with all of the other data that you can put in, whether that be people, assets, number of beds, you can build it into whatever you want. And then it takes all of that, and then where you get the power is then the leverage of all of that data together, not reliant on individuals, one person's experience of how they've done that for the last 30 years. It captures it all. And obviously for us now, that's a big problem because we're losing so much experience. You know, all of the grey hairs are taking their really nice retirement packages, and we've got keen young engineers that are great, but yes, Chris, you. But actually, we are losing a huge amount of experience. So you can use then all of that for the decision making. So really, how does that sit within what we do? You know, we have our normal program management, our P6 plans and everything else that we do here, which is very set. And then you have the change that hits us. So if I say for an offshore shutdown, we spend a year planning it and everything else, but it's all set up on what we think is going to happen. And then we go offshore and you open up a separator and something's different and it all goes to pot straight away. Actually, having the ability to take all of the data and a model and all of the information, within the shipyard, what they've managed to find is actually it's really quick and easy to do a quick simulation and say, right, here's some big risks. How do we change that? It helps with all of your decision making. It looks at all of the logistics and the flow of how things work in much more detail than we can usually think about. And from there, you can go into sort of a much more refined adaptive planning rather than are sort of deterministic, and I'll go into that in a second. But also the biggest bits that I'm looking at as well at the moment is your continuous improvement, but also capturing all of the experience that you have. How do you, that actually slowly gets absorbed into the system to a degree, and that's what they've spent the last 20 years looking at, is when they're looking from the factory through, how do you capture the things of, well, somebody's walking here rather than just appearing, and how do you get your equipment there, and how does all of that work fit in together? And then they've taken it further, whereby they've got a full 3D model of everything. Well, why don't they use that through the build? So you can walk through one of their builds and you can hold up an iPad and you can see through the camera what is half built and then overlaid everything that is to be built yet. And that they use that day on day. And we're still just playing around with it now. They've been using it for 10, 15 years. So there's so much to this that I'm trying to capture. But the key bit really at the moment that we're playing with when we're looking at a shutdown is at the moment, historically, we've always done this sort of deterministic plan. And it's cool, we have start, finish to finish type activities. We spend a year developing this schedule based upon the experience of the team. And what that gives us is this great plan. It gives us a critical path through all of the activities that we're trying to do. But it relies on the team and the individuals to actually think about all of the what-ifs and build it in. And then when you go offshore, when something doesn't work to plan, everybody scuttles around and tries to replan it and build it up. You know, but the reality is if you use stochastic planning where you actually get rid of all of the links and the constraints, or you put in the absolute bare minimum, what you do then is you're starting to let the system analyze and tell you what's happening. So when you saw that animation at the beginning, what you see is a whole lot of activities built in, saying, okay, this might have to go before that, but other than that, it's incredibly loose. And then it lets the system work out how long and what's the quickest way for somebody to get somewhere. Is there something else there in the way? And it builds up on all of the data to say, how do we do that? And so they've then built, over time, these various probabilistic curves on different activities. So when you do a run through the system and you run a schedule, the next time you run the schedule, it's different. And you can keep running it. And then you start to see patterns of behavior within the system. And you can use that version of planning much better to sort of hold on to what you're trying to do. But also you can look ahead. And so what we've done really is, it's great showing everybody an aircraft carrier, but people go, that's great, that's an aircraft carrier. And some people really see it and some people don't. So with the kind help of one operator, we took a jacket. They gave us a very crude model. And we programmed in an actual shutdown. just to say, what value do we have? Now, I'm not going to be able to talk through this as quick as this will play. But what you see here is we stripped out all of the links of a shutdown. Well, we ran the schedule as it came, actually. And you see it flashing through different colors in different areas. Rather than do absolute infinitesimal detail, we took it to quite a high level, just block areas. Each of these activities, all of these colors identify that an activity is happening in an area on the shutdown. But what you can see, or what you could see, I'll play it again. What you can see in here is every now and then there's a bit goes purple, or a bit goes red, or a bit goes yellow. And what those indicate is there's some red bits that flash up saying, actually, that's when work was all halted because there was a delay. And that was an actual shutdown. If we'd run that and now that plan before they'd started, we would have been able to say, hey, look, for 3 days you had to stop there and wait. And actually within, I think a simulation on this takes about 30 seconds to run an entire shutdown. And you can change the speed in the simulation. I'll run it again. And it allows us to really quickly analyze a shutdown and say, well, you could maybe use some more respirators here. And you could maybe change that activity around because you're short of beds. And so we have the ability, because it's just data, to analyze a huge amount of information really, really quickly and actually look at how do you compress a schedule. So we're looking at the moment of, can you save a day on a shutdown? And then if you have an issue offshore, how can you adapt really quickly to that change? Because change will come, it's inevitable. So, you know, as I said before, with our biggest challenge at the moment is, you know, we're losing a huge amount of experience. How do we capture that? How do we hold on to that? And going forward, as we need to be leaner, how do we make the best use of the people that we have without them spending hours and hours doing routine planning and looking at what ifs when we have systems that can do it? And just, as I said, getting the predictability of target. We want to go offshore and we want to know what to do when something changes, but invariably want to know that actually the plan that we've got is pretty sort of sound and proofed. So that's what we've been doing at the moment, and I might make our 20 minutes here. The system is huge. It's got 25 years of development and it's been used, and its budget has been massive, and we get to steal it for free, which is really cool. But, you know, CapEx projects, I mean, the aircraft carriers it's used to build those, it throws out something like 3,000 work packs a week, and it can adapt and change those work packs every day, depending on what was done and what wasn't done. And that's been used for years. It's been used to do decommissioning of nuclear submarines and actually of some facilities in the US, managing where individual people have to stand during an operation. I think one of the slides before had, you know, to minimize any impacts to the materials that they're handling. Some of the things I've been talking with different clients at the moment is, how do you share operations? You know, helicopter logistics across an entire swathe of fields, rather than you're all using helicopters on a Monday and then them sitting on the deck between Wednesday and Sunday. How can you sort of plan an individual activity to make sure that actually it's as efficient as absolutely possible? And it can do all of the different levels. So once you have the models, you can use it for training. And actually then it does start to take in the data. So some of the things the shipyard's starting to use now is, how does it use machine learning? How does it take the previous programs and automatically adapt the new things you're doing? And also, how do you build that into a smart factory? So that's stuff that is rolling at the moment, and it is moving into that. And some of our challenges, yes, this is something really, for us, it's new, and we really don't like change. Our previous investment, we've spent a fortune on P6 over the years and planners, and it does change that a little bit. But actually, it doesn't entirely throw that out, because we still use P6, and we always will, I think, to a degree. One of the challenges we have, you'll see the difference between the carrier video and the platform video, is the level of detail you model. You could model, you know, down to every nut and bolt on a jacket, but do we really need to? So there's a challenge in that, and I guess there's the fear that this system could replace jobs, and I know that's something they've had to fight in the shipyard. But the reality is we're struggling for people. We will soon especially be struggling for people and experience, and this is a way of capturing it, so we allow our people to work a little bit more efficiently. And Nikki, I'm going to say, There you go. I'm going to beat you 20 minutes.
Not even. Look at that.
I know.
I can ask you to show your thanks to Mike. Straight to the top of the class, finishing early. Okay, so what questions have we got for Mike today? And as ever, sorry, I should have said, make sure you wait for the mic if you have a question, just so we can make sure we can pick it up.
Hi, Roger Essen. I'm the Decommissioning Solution Centre Manager here at OGTC. Very interested in the decommissioning part because we've got a number of operators in the North Sea. We've got complex infrastructure to decommission, multiple assets over a 35-year period. Mm-hmm. Is that something we can realistically model? Because we are seeing that there's a certain band of people out there who are not seeing any value in campaigning some of these things. So is that something we could model? I
think there's certainly two aspects to it, in the sense of you could look at the details of the decommissioning from the point of view of the model, how do you break things apart the most efficiently, but also then actually, the shared logistics, the campaign thing, when you start to say, okay, if we're doing 4 things in different areas, how do we best reuse the resources by, because it can do a much larger geospatial type modeling, saying, okay, we need these vessels here and that piece of equipment here and these people here, and where do we keep the workforce to manage all of that? Actually, the ability to simulate and analyze hundreds of different simulations really, really quickly to come to a best idea of how a plan might work and how much efficiency might you gain versus doing each campaign separately, yes, it could.
I'll talk to you after this. Thank you.
Okay, next question, please. Oh, Stephen.
So you're going to see a bit of a theme here. So Steve
okay.
Ashley, Digital Transformation Solution Centre Manager here at OGTC. So we have a lot of discussions with people about simulating operations.
Yes.
So the shared logistics, that's an impact. You talked a little about planning shutdowns and then I guess startups again.
Yeah.
But obviously we have a lot of unplanned shutdowns and the ability to predict and maybe simulate the likelihood of which type of shutdowns, non-planned shutdowns, would occur would be interesting. Do you think would it sort of be able to cope with that sort of thing? I guess
it's the initial having the model infrastructure built up. And that's probably where we are at the moment. We're talking with one client and they've given us a swathe of data, and actually it is really capable at sucking data from loads of different areas and creating this. They have a name for it, and it jumps my mind right now, but it's almost like a common support framework, they call it, which is this sort of data bundle. If we've worked through stages where, and actually doing that jacket was really quick, and so I know most people have some level of data. If we're able to get that really quickly, you could then go through a very quick decision process of building it together. I mean, they've made this as simple as possible to use. So you have the engine in the background, for want of a way of talking about it from a gaming perspective. And then really you just have Excel sheets and you suck those in to do the basic simulation. And you can batch run stuff and all things. I've got loads of videos that I just had no time to throw into here. But you can build all of that in. So actually, that would be your biggest constraint probably up front. So if you've already got that model, for example, it would be really easy then to just do a quick simulation on it. Yes.
Okay, and next question. Graham?
Hey, nice one, Mike. Graham Rogerson, another OGTC staffy. I was just going to ask, if you had a magic wand, you've obviously looked at this software quite a bit.
Yeah.
It's maybe not been used in oil and gas industry yet, but so where would you go first to make the biggest impact?
I think that, as you say, when I've gone into it, the software is, and actually the system is huge, and its capabilities across so many different areas is huge. For us, when we've looked at the current drivers at the moment, like all of the efficiency task force, we thought actually the shutdowns was a great place to focus, just because having spoken to a few clients, no one gets it perfect. One platform might be good, another perfect platform not quite so good. And so our plan really was to look at that. But actually, there's so many different things from the point of view of even just the whole training, modeling, simulation piece is there. For me, if I had a magic wand, what would I do? At the moment, they're building a team to help me continue developing this, and it would be to be able to have actually model programs that I can run alongside. So we've already have one client where we're running this system alongside an existing decommissioning, almost to show the benefits of it, but then over time to actually say, well, why don't you help us do the decision making to allow you then to plan it more precisely, and then slowly you could take over that whole role. But it's actually having programs that we can run in parallel with, just to show how useful it is and how good it is compared to sometimes how we work at the moment. Does that answer your question? Sort of. Okay.
Do you want to go again, Graham?
So
I guess I'm just keen, you're saying it's... Oh, sorry. Yeah, it's really broad, eh? I get that.
yeah.
But it's your bit of software. So I was just wanting to know, yeah, you got a magic wand. Where would
I have it? I would have it as a
decom project, current operations, new build.
I think current operations, and just looking at all of our efficiency piece as a portal where people can log in, because the advantage of having it in one place where all of the data feeds is then as it starts to capture all of the data, it improves everybody's practices, not just one person's. And so actually overall everybody would benefit from a good shutdown or basic operations, and have a common area in which they're able to do their various bits of models, but still control their own data and everything else. Does that better answer your question? Good.
Okay, and next question, please. Oh, Susie at the back.
Hi, Susie Wiseman, another OGTC staff member. So obviously you presented all the benefits of using it. Do you see any drawbacks?
Well, I think, yeah, I tried to sort of put some of that from here. I mean, the reality is it's a huge piece of software, with years of development, actually, and it's trying to pick out how can we make best use of it without getting lost in detail. When we've looked at doing the shutdown, how much detail do you go down to? Because you could go down to, in a shutdown, where does a person stand to undo the bolts? Where do they put the bolts? What do they get put into, and how do you follow where they go? I mean, you could go down to that level, because that's what they do for the nuclear piece, because it does need to go down to that level. But we don't need to do that here. So really, level of detail, and actually then, after that, I know people are going to ask, well, what about the sensitivity of my data? How do you look after all of that? That will be the other question, which is usually been part of our stumbling blocks for different things like this in the past.
I guess like any other tool, the quality of the data you input will determine the quality of the output.
Absolutely.
Thank you. I feel I need to ask, do any of our external guests want to ask a question? Or is our OGTC team are all over you, say? It's gentleman at the back here. Oh, sorry.
Sorry, Alan, Mike. Maybe just a suggestion on the operation standpoint.
Yeah.
Frequency testing or the run-out predictability. Just test and try in the US. US line-based stuff. It's less detail on the platform, but more detail on logistics and everything else.
Yes.
Right, so.
Yeah.
Thank you. And this gentleman here.
Tom from R2S. I was just wondering if you could expand a bit more on the, a lot of operators have problems with the level of detail they actually have about their assets, particularly older assets, with 3D models being created well after construction and very rudimentarily, how that impacts on it. So
I think, obviously, for things like the actual carrier example, their models built in through design and they have them all there. When they did the shipyard piece, I mean, the shipyards have been there since the mid-1800s. So here's a shipyard, how do I model it? So they have done a huge amount in the way of doing cloud point surveys, so literally dropping a laser down and then mapping the whole thing. And so actually, and I can come back to you with a bit more detail, But my understanding is a lot of that will actually not only do the scan, but they've built systems that will actually then identify what those components are and almost start to auto-populate the database of his pipe, it's this pipe, it does this. I can imagine it's not perfect, but again, that's how they've sort of captured a lot of the older data. And in the sense of here, we had about 2/3 of the model. And so we were able then to just to say, right, what level do we work at based upon the information we've got? It's still better than running with no information. And so we've used as much as we can. This is one of our platforms in the North Sea. I'm not going to tell you which one it is. And we had most of the data for it, but not all. But it was actually quite easy to say we're going to be doing these activities in this area, and where there are gaps, you can build a box and just work within that, and it still gives you a huge amount more information than we currently work with. So you can run it at quite a high level and get an awful lot of usage out of it.
Thanks. Next question. Haven't missed anyone this time. Eh? Chris?
Thank you. Chris Pearson, another OGTC marginal fields person. There's two questions for you, Mike. I think the first one's slightly hypothetical. If we were to go and design a facility of the future, by chance, as it were, that was fully automated, and we were to then model it for, say, over 5 years, do you think that would be a good concept for your software to model and look at the operational detail, how we intervene with the automated equipment, how we land and interact in this sort of automated environment, etc.?
I guess because it's from the physical environment and that whole geospatial piece and movement and how do you get to stuff. And yes, from the actual, when I think about what you're talking about, unmanned maybe and remote and the digital portion of that, I couldn't answer about the digital piece because that's obviously less about where things are going and how they're moving. But yes, certainly from a point of view of looking at how you manage and plan and operate a facility that's generally a lot more unmanned or remote or automatic, then yeah.
Okay. So if that hypothetical piece was then real and it was actually a real project, would you like to get involved in it?
Yes.
Sorry for setting you up a little bit.
I guess what you do with that simulation then is, and I'm going to flick here and guess, what you're trying to do with that then is you're starting to try and build much more accurate sort of probabilistic curves of how are the behaviors and the patterns of things happening that allow you to better model, what actually happens compared to our sort of current, well, we're going to do this in 8 hours in this time. Yeah.
So that was a yes.
Yes.
Thank you. Okay, I think we've got time for maybe one or two other questions. Is any more questions for Mike? Looks like you might be getting off.
Cool.
Last call. Okay then, I think in that case, can I just ask you again to show your thanks for our speaker today?